Today is the first day of batch 13. We are going to start with the CAN because this course deals with the CAN standard and then how to use the CAN standard in day-to-day life of an automotive engineer. First, some 6 hours, we will study about the basics of CAN. Purely, this training is focusing only on the technical stuff. What is the necessary skill needed for an automotive engineer to survive, to do his day-to-day works in the automotive? That is covered here. Also, this training mostly focus only on the system testing. Like developer engineer can do this. This training is very much useful for the system testing engineer. Those who want to have a testing related career and those who prefer testing, for them, this is very great opportunity with respect to if you want to find a job in automotive industry, this training will be very much beneficial to you. That is how the course overview. Agenda for today is studying the CAN in detail. So don't think like only I have to speak, you have to listen. Not like that. You please interrupt me when you don't understand something. I am ready to explain. The course will be mostly a practical one. So no need to hesitate. I am not a professor. You no need to hesitate to ask the questions. I will surely explain that to you. I believe this course will be very much helpful to you people. Let us start the training. First thing that we are going to see in this one is history of CAN. First of all, what is control area network? What is CAN? That we have to know. How this CAN evolved, from where it evolved. So those knowledge is needed. Okay, no? Most of you know about those who studied about the microcontroller 8051 or PIC microcontroller. You know about something called as RS-232 communication. How many of you know about it? Did you hear about COM ports, RS-232 communications, all these stuffs? Those who know embedded system or basic device interfacing with the PC, they know about that RS-232. Yes, RS-232 is nothing but it's very simple. Let me draw a diagram so that you will understand. Most of you have used USB interfacing device like mobile charger, data reader from the mobile, and then every one of you are using USB based devices. All USB based devices are using something called as universal serial bus, USB. The mother of that one is RS-232. So what is RS-232? First of all, let us know about that first and then we will come back to CAN. There are two ways in which the computer communication works, otherwise computer network works. One is a parallel transmission. What is parallel transmission? When they want to transmit 8-bit, means they will do that via 8 lines. So when you want to transmit 8 bits, they will do it via 8 lines. When they want to transmit 16 bits at a time, they will use a 16-bit line. So that is called as parallel communication. When you have a device, you have another device, you want to communicate with that device. When you communicate, if you transmit 1 byte at a time, that means 8-bit means you will use 8 line in case of parallel communication. So it is hardware sensitive. So you have to have a lengthy cables with more cable and it has more lines. If something goes wrong in any one of the line, data will become error. So you cannot reproduce at the receiver end. This is the challenge that we have in the parallel communication. So at a time, you will transmit 8-bit in 8 different lines. But the same 8-bit, you can do it in another way. That is called as serial communication. In that, what you will do, you will transmit the bit by bit. So instead of transmitting all 8-bit one time, you will do something different. What is that? So you will have, let's say this is your transmitter. TX node, this is your RX. This is your TX. This is your RX. So in case of serial, what they will do, they will transmit the bit by bit. They used to have a TX line, and then the 8-bit will go serially to the receiver. When you do like that, you have a problem. When you send a series of bits one after another, what is the division? Like, what is called as one bit? What is a boundary for one bit? For that only, they will use another signal called clock. The clock is needed to do a serial communication in the earlier days. Clock is needed. So there will be, if I send one pulse of clock, I will push one bit. So the receiver has to take, for one clock pulse, it has to see at that clock pulse, what is the value of the voltage. If the voltage is 5 volt, it will consider that as 1. If it is 0 volt, it will consider that as 0. So like that. This is called, initially the serial communication had a baseline of clock. There you should have a clock. Before doing any transmission, first you have to achieve the clock synchronization. You have to achieve the clock synchronization between your transmitter and receiver. This is called a synchronous communication. Synchronous communication means for one clock pulse, I will transmit one bit. Like that, if I want to transmit 250 bits, means I will do that in 250 different clock pulses. Initially, when I want to transmit, I will synchronize my transmitter clock with the receiver clock, and then I will push bit by bit. This is called a serial communication. This is parallel communication. This is serial communication. This is very common in the computer network. So when you want to communicate to the external world, when you want to communicate a data from one device to another device, you have to follow either parallel or serial. But this method is obsolete. This method is not used in the market now. It's gone. In olden days, maybe I believe whether you people saw those cables inside the CPU, you can find ribbon cables. Those times were gone. Nowadays, people don't like parallel cable at all. Parallel communication is gone. Everything, whatever you are using, right? Your TCP, IP, and then the Wi-Fi communication, USB communication, and then RS-232, CAN, everything is serial. None of them are parallel. Because serial communication itself, they are able to achieve most of the things that they want. Again, when you want to do a serial communication, if you have 2 or 3 wire, that is enough. TX, RX, and then a ground is enough to do the serial communication. So the cable wise, you have a hardware wise, you need minimal wire connections. Again, you can also do better performance than the parallel communication. That's why the people moved to this serial communication. Among this, the very first communication, the serial communication introduced was SCI, Serial Communication Interface. They used to call it as SSCI. That means SSCI means synchronous serial communication. The synchronous serial communication used to have a clock as a baseline, and then initially they will synchronize the clock with the receiver, and then they will shift the bits. Later, after that, they come to standard serial communication, universal synchronous communication interface, serial communication. That was asynchronous serial communication interface. That means there is no need of clock in that method. That method is working in such a way that when they want to transmit something to the receiver, they will initially notify the receiver that, hey, I am going to send something. That is denoted via a single bit called start of frame. It is just like a jerk that you are producing in the communication link. The moment you produce that jerk, the receiver will come to know that, okay, something going to happen. So that is called a startup frame. After sending the startup frame, they will shift the bit one after another. The both of them, the transmitter and receiver, are synchronized with something called as baud rate. The rate at which I am going to transmit, that is known to both of them. The receiver will try to sample the incoming bits based on the baud rate. The moment the transmitter wants to end the communication, it will send the end of frame. So the startup frame is to denote that it is going to transmit, and the end of frame that it has completed the transmission. These sort of handshakes without the clock, if you include these sort of handshakes, the clock is not needed. The clock is not needed. That is called as asynchronous serial communication. USART or UART, like that they used to call it. That serial communication that was implemented initially, that can transmit only 1 byte in a one packet. So they will transmit the data frame by frame. When they want to transmit 8 byte of data, they will put that in a packet and then they will send it out. The maximum capacity of serial communication interface, otherwise the RS-232 communication, is 1 byte in a packet. That means 8 bit in a packet. The RS-232 communication also has baud rate, it has a TX and RX pin and ground pin, everything. The only difference between the CAN and RS-232, CAN can transmit 8 byte in one packet, whereas the RS-232 transmit only 1 byte in a packet. Again, there is no concept of arbitration, error handling. Those stuffs are not up to the mark in the serial communication. Whereas in CAN, it is very good. Like they have a lot of things like error handling and fault confinement and many things. Because of that, the CAN becomes popular. CAN is also a serial communication interface only, serial communication standard only. You to have an idea about RS-232, let me show some example. Most of you had seen like a flashing device that you have for your microcontroller, and then every instrumentation, intelligent instrument will interface with the PC via RS-232 only. Here there is an example. Let me check some images so that you will come to know what is RS-232 first of all. You should know that first. Even in olden days, printers were like that, RS-232 printers, serial printers. See here, laptop we have, and the printer is in another device. The printer is connected with the laptop using USB, which is nothing but a serial communication only. The same RS-232, but the speed is a little bit high, that's all. They are using USB standard. Programmable power supply are interfaced with the PC via RS-232 communication. The flashing devices are interfaced with the PC via RS-232 communication. Usually the RS-232 cable will be something like this. It used to have, see here, it is having an TX, RX and ground. 3 pins are enough to do RS-232 communication. The same 3 pins are enough to do CAN communication as well. But only thing is, the RS-232 communication will transmit only 1 byte at a time. In a frame, 1 byte only can go from transmitter to receiver. But in CAN, you can go up to 8 byte, nearly 64 bits you can do. If you take CAN FD, you can go up to 64 bytes, 4096 bit in a packet. There is a number of bits that you transmit in a CAN packet is more than the RS, but the standard wise, there are many commonalities. Otherwise, the both of them share a common ground in many things like baud rate and then the standard, the serial transmissions, everything. Are you able to get an idea about RS-232? What is RS-232 now? Yes or no? Every electronic equipment, when you want to interface that with a PC, they use this RS-232. It is very easiest way to exchange information, the bytes from one device to another device. See, we have a PC, we have another electronic. Assume you have an CRO. You want to get the waveform that you captured in your CRO to the PC. There should be an exchange of information from your CRO. The PC should get the data. How will you get that? If that is the case, both of them should communicate in some means. So there should be a communication interface. The very cheap, famous, reliable communication in olden days, this RS-232. Every microcontroller, even today, every microcontroller that you see in the market used to have RS-232 interface. Without that, it is very rare. You can find one way or other way around. Every microcontroller used to have this interface because it is very easy to bring, because microcontroller need an external code to be imported to the microcontroller memory. Then only it can perform whatever the action that we want. How will you bring a code from a PC to the microcontroller? Let me tell you another example. You have written a microcontroller program in your PC, but you have to flash that program to the microcontroller. From the PC, you cannot execute it because PC is not a microcontroller, it is a microprocessor. So what you do, you use something called as a flashing. If you take a PIC controller, you have a PIC kit 2. Maybe in the Atmel and then 8051, they have their own flashing software. What this flashing software used to do, it used to take your executable code and then it will transmit that in serial communication. So it will simply send byte by byte from the PC to that microcontroller. There is an already available code inside the microcontroller. It will simply take that code and they will write it in the memory. So when you want to exchange information between devices, you need a communication channel. In olden days, very famous from in 1980, before that we have that one. Even the beginning of this flight communication, the flight used to communicate with airport authority, but maybe, I don't know, now it might be modernized. In the very initially, the RS-232 communication only used to communicate from the flight to the tracking center or something like that. They will communicate only via that only. It's very famous. It's being there from World War II. The evolved version of RS-232 only the CAN. The CAN is not like something new which come from the heaven and then it's a new technology. People invented that from the scratch. Don't think like that. The CAN is a developed an advanced version of RS-232 communication, nothing more than that. Are you clear about RS-232? What is RS-232 communication now?
Yes. Yes, it is cleared.